We did in the last session we went through what is called as the stack, which we implemented using a linked list. Today also we are going to add only two functions. We are going to learn only two functions. I am going to roughly describe them how to do it. Then as usual, we did in the last class, I am going to give you some time. We have to write two functions. What are those? NQ for putting into the queue, DQ for removing from the queue. Okay, DQ is a word which is used often. It is also means double-ended queue. That is not the intention we are doing. For us, DQ means reverse of NQ, taking out of the queue, we are saying is DQ. So that is what we are going to implement. So I am going to show you on our screen how to implement it, and hopefully you will understand and do it on your own. The trick is, because a queue is what kind of a data structure? It's a FIFO data structure. First in, first out. Stack, was a LIFO data structure. Whatever we added, we took it out. Now we have to be careful. We'll have to maintain a head pointer, of course, and we'll also have to maintain a tail pointer. So we'll have two pointers, not just head. We'll have a tail also, and tail will point to the end. Initially, head and tail both will be null. When you add one node, head and tail will point to that node. When you add more than one node, tail will be somewhere, head will be somewhere. I mean, they will be different from each other. Only if there are two or more nodes. If it is a single node, there will be a head, there will be a tail, but both will point to the same guy because it's just one node queue. So that's what we will do. I am just going to describe how our linked list with queue, behaving as a queue, is going to come in. Okay. So initially, head will be null, and I am going to introduce a tail. Tail will also be null. So initially there is nothing. So you'll have to check when you NQ. So NQ, the logic for NQ goes something like this. Check if head is null. Sorry. Check if head is null. If head is null, obviously tail will also be null. If you're consistent, isn't it? You can't have a head null and tail something else. Not possible. Check if head is null, and if head is null, then allocate a node with that appropriate data and make head is equal to tail is equal to the temp. Correct? Temp is that memory that you are allocating. So head is equal to tail is equal to temp. This is if head is null. This is called first step in NQ. I'll say step 1. Okay. Step 2. Let me go to the next page. If head and tail, that is, when will this happen? When there is just one node on the list, then only head and tail will be same and pointing to that node. So head is equal to tail means there is only one node on the list. So if it doesn't matter here, so what will you do? Allocate a new node with that appropriate data, temp. This is temp. Then say tails next equal to temp, and tail now becomes temp. Correct? Anyway, this code is going to be common in the next scenario also. Anyway, head doesn't change here, only the tail will change. Correct? If head equal tail, allocate a new node. What do you do with that new node? It should go to the tail. NQ always adds new values to the end. Remember, it has to implement a FIFO, first in, first out, like a queue. So tail is equal to temp. Tail will change and will now point to temp. Else what do I do? Else when does it happen? Head is not null, head is not equal to tail, there is 2 or more nodes on the list, correct? I will come to the else part only when 2 or more nodes are there on the list. Then what? Add it to the tail. It is the same logic. Tail's next is temp, okay, and tail also equal to temp. So in this case or this case, actually you could merge these cases. Tail equal to temp, and in all these cases, at the end you should say return head, which will change only in the first case. Okay, all these cases you return head. This is the NQ operation, correct? Now, let me go back. Okay. So if head and tail initially are null, check if the head is null, allocate a node always, and make head and tail equal to the same thing. Next thing, if head equal tail, actually you don't need these two conditions. You can just say else in the previous thing. That is, head and tail are, doesn't matter if they are equal or not, you are going to add it to the tail. So this condition can be knocked out, because if you see, the logic that I am doing here is exactly same as that. So why do I need a separate if? This can be the else of the original if itself. And then return head. This is NQ. What will be DQ? So DQ will return an int in the first in, first out order. So can you tell me what DQ will be? If head equal to null, what does it mean? There is nothing in the queue. No, yes. If head is null, there is nothing in the queue. So I don't do anything in the queue. So I'll say if head null, do nothing, because return, you can return an underflow if you want, but we are saying no. You can also do the overflow in NQ for size, same logic. Head is null, return, you can give a printf and return a -1. Before that you can do a printf, it's an underflow, there's nothing in the queue, yes, yet you are trying to do a DQ. Else, that means head is not null. So what will you do? You'll have to advance the head and free the head. So you will have to say temp equal to head, something like this. Head is equal to heads next. You have to move the head forward, correct? Temp is equal to head. Temp points to the first guy, which you have to free. Head is equal to heads next. And you have to say, now temp is equal to head. Now you can't free it. So you'll need to have a value. Int v is equal to temps data. And then you have to say free head or temp. Not head, it should be temp, this thing. Head has moved ahead, temps data, free temp, and return v, okay? Something like this. That's it, you're done. If head is null, this is what it is, return -1. Now, should you update tail? No need. Why should the tail change? If head becomes null, you are checking when it is empty. Otherwise, tail will stay where it is, isn't it? Head will move forward. So tail doesn't have to change when you are dequeuing. Okay. So this is what, and you can see size. I have not put size. So if size is 0, cur size is 0, then you give an error that return -1, or head is null. It doesn't matter whichever. But whenever you NQ, also increment, DQ, you also, if you are using cur size, decrement the cur size. I have not added that code. And similarly, while NQing, you have to add to the cur size so that cur size remains current, and you have underflow and overflow. Okay. Now, I think at this stage, I don't think I need to talk anything more. So I'll give you that code, which we did last session, and I'm hoping that most of you will be able to do it. Okay, so we'll give you lab 51. So you have to add two functions, NQ and DQ. Then I'll make changes to the main and I'll show you what the main should look like. We'll give you the main. We'll change the main and give. Copy to 51, then we'll edit it. Before you save it, let's edit it. We'll edit the main so that it tests the Q, NQ and DQ. The push and pop are not needed, but let's keep them, but we'll remove them from main. Okay. So we'll take off all this. Okay. And let's do a NQ, DQ. Let's change the main. In main, I'll say NQ 10, NQ 20, NQ 30, NQ 40, NQ 50. So NQ 60 shouldn't happen. At NQ 60, I should get an error, say, because we said our size of your queue, just like the size of the stack, should be only 5 elements. Okay. So when I say NQ 60, no, why are we going there? Yeah. NQ 60, I should get a printf, overflow, and it should say whatever, some error. You can't do, or just overflow error. Then we'll say DQ. NQ is a void function, doesn't return anything. DQ returns an int because it's a queue of ints. So, okay, now we'll write a bunch of DQs. So we'll say printf %d space DQ. DQ returns an int. Okay. Then printf %d again. Okay. Again DQ. Then we'll do an NQ in between. After 67, we'll do an NQ 70. Just say NQ 70. Then we'll say DQ and we'll do a couple of more DQs. 5, no, 6, 7. One more, 2 more DQs. Now, before we start, can you tell me the answer of the first DQ? We are entering in 10, 20, 30, 40, 50, 60. Remember, it's a queue. First in, first out. So the first DQ should give us 10, second DQ 20, third DQ 30, fourth, now it will be 40, 50 and 70, correct? 60 has not gone in because we said size we are going to check and 5 is the max. Our size cannot be more than 5 without a DQ, that is. Maximum data in the queue can be only 5 elements. So now it will be 40, 50 and 70. So now DQ, line number 69 DQ will give me 40, line number 70 DQ will give me 50 and line number 71 will give me 70 and line number 72 will give me a underflow. And we don't need 73. Okay. Anyway, any line after that will give me an underflow. Okay. It doesn't matter. Okay, because there is nothing in the queue. So the head is null. You can't do DQ on a queue whose head is null. Okay, so I have given you the main code. You take this main code. This is called lab 51. We will give it to you. Already we gave you has push and pop. You don't need that. You don't need to remove it either. That is, if you want to use it as a stack, use push and pop. If you want to use it as a queue, use NQ and DQ. Okay. If you want last in first out behavior, that is stack, push, pop. Otherwise use NQ, DQ. So you have to write these two extra functions, NQ and DQ, and and make this program work the way we want it to work. You can take push pop and change it. Yes, copy push pop and change it if you want. Whatever, whichever way you want. Only thing is there will be a tail pointer coming in. You have to add an extra variable in your global, which is tail, to keep track of your tail. Okay. So we will need the tail pointer, and that's all. Otherwise I have given you most of the pseudo code. Now you write it and I will wait. So write two functions, NQ, which adds to the queue, DQ, which takes it out from the queue, okay, and freeze it. Yeah, we'll wait for you to finish. Okay. So we'll add two more functions. We don't need any support functions, I think. So we'll call the first function as NQ. DQ returns a value. NQ does not take, just takes a value, but it does not return anything. So it's a void. So void NQ, it takes a D as a parameter, int D. It enqueues that data after creating a node, int D. So at least those of you who are not able to do, watch. So we have to add an extra pointer in the outside called tail. So we'll do that at the top, where we have head, line 8, उसके बाद line 8, या उसके पहले, struct node star, it's also a node pointer, start tail equal to null. So initially head and tail both are null. Okay, so we go to NQ now. We have added that variable tail. Okay, now we can do check in whichever way. We can get an overflow in various ways. We can say if cur size equal to size already, then there itself we can say we can't NQ and return an overflow. Okay, are you with me? You can write that condition at the top itself and then write the whole code in else. So we can say if cur size equal to size equal size. Remember we did something like this last time also. Cur size equal size, that means already that many elements are NQ. You can't add another element unless you do some dequeuing. So unless you remove some elements from the FIFO, from the queue, you can't do. So in this case, we just say printf overflow, because we can't NQ, overflow in double quotes. Okay, I think with a space, because there needs to be a space between that and the next. Yeah, so that's that. So that's it. So if cur size equal size, we simply say printf overflow. It's coming in same line, so no \n, nothing. Okay. Okay. So else means there is space in the queue, we can add. Else, now comes the logic for adding, which is if head equal tail equal null, we can write that, or we can just say head equal to null. That means tail will also be null if our logic is consistent. So we'll say if head equal null, that means it's the very first node which is getting created in the list. The list is as of now empty, head is null. So head equal null, head is empty. What will I do? As usual in any case, I have to create a fresh node. So I have to do an malloc. So I'll say struct node start temp. Struct node start temp is equal to, you know how to allocate a new node. You have to cast that pointer to a node pointer and do a malloc. So struct node star temp equal to struct node star temp equal to struct node star malloc, okay, struct node. So I have allocated that much memory first time, is the first time head is null. So now what will I do? Temps data is equal to D. This is how I do things, no? Temps data is equal to D, and by condition temps next should be null. We'll adjust it later if you want. But whenever you create something, no, make next as null first. You'll be on the safe side. Later, if you need it to be something else, you can do that. So temps next is equal to null. Okay. Temp data is equal to D, temp next is equal to null. Okay. Now this was all under the condition head is null. So if head is null, tail also must be null. And when I am creating this node, at the end of this creation, I should say head and tail, head equal to tail equal to temp. Okay, is this allowed? Assigning like this? Allowed or not allowed? Not allowed. Yes, sir. A equal to B equal to C. Allowed, no? Yes, sir. What will happen? First temp will be assigned to tail, then tail will be assigned to head. It's allowed, but it is right to left. It happens in the right to left fashion. Okay? So, but it's allowed. Head equal to tail equal to temp. Or if you don't want that, you say head equal to temp, tail also equal to temp. No problem. Okay? And so we have successfully enqueued the data. That is, we have created a list was empty. We created a list with one node and we have updated the head and that's it. So we just say return because it's a void. I have to just say return. I have added one node, so cur size should become 1. Good catch. Isn't it? The first node was added to that empty list, so cur size should become 1. Yes, very much correct. Size. You can say cur size equal to 0. Cur size plus plus will also work. No, because anyway it is 0. Okay. Doesn't matter. It's the same. Okay. You can say cur size plus plus. No problem. It is anyway 0. Okay. Because head is null. So now head and tail are pointing to the first node, the node which got created. So let's write else. Else. Else means head is not null. That means there is something in the list already. So, okay, and cur size is not size. Okay, so we have to add. Now it becomes easy. We can have only one situation. Now we have to add to the tail, correct? So again we create the node. We are copying it again. This is again allocating a node. Okay, now the head is not null. So head will stay where it is, correct? And values will get added to the tail. So we will say now we have created a fresh value temp. So we will say temp's data, okay, is equal to D, the same thing. And temp's next equal to null. Okay. And this should become the current tail's next. Do you agree? I am adding to the end, so obviously it should become whatever the tail right now, his next. So tail's next, this is perhaps the most important line, tail's next is equal to temp. Okay. See, I am creating on line 76. Now head is not null. That means there are some nodes in the list. Okay, so we have to add it to the tail. That's why it's FIFO. So what we are doing, we are allocating the node, putting the data in it, putting the null, last element null, then tail's next is equal to temp and his next is null. So that's the end of the list. And one more line, cur size is equal to cur size plus 1. Plus 1 because we have added a fresh node. And is that all? Do I need anything more? Or should I say return? Return, huh? Tail has not changed, correct? Tail has not changed. Tails next is temp. Now where should tail be? Tail equal tails next, or tail equal temp, whatever. Tail equal temp. See, I have connected the temp to the tail. Tails next has become temp. So tail should become temp. Tail is growing. So tail should become temp. Okay, once again, first line 76, node got created, node got filled with appropriate data. Then we said tails next is equal to temp. We started adding temp to tail. Then cursa is equal to cursa is plus 1 because we have added a fresh node. And what is the new tail? The new tail is the temp now, which is added to the old tails next. So that is temp. And now we say return. You have to be careful. Just think a little. Return, that's it. No value for return. Okay. So this is how I write my, let's go up. This is how I write my NQ. I take care of two conditions. Head equal null, what should I do? If head is not null, what should I do? Head is null means head and tail both are null. It can't be otherwise. And in that case, I create a fresh node, assign head to that node, tail also to that node, make my cursa is 1. This is the first node because just now head was null. Head is not null, that means something is already there. So I have to grow the tail. So that's the beauty. I have kept a tail pointer. So I created temp on line 76, 77, 78, then made current tails next as temp, then added 1 to the size, tail we made it as temp and we returned. My NQ is over. Okay. Now I write my DQ. DQ gives an int answer because it's supposed to pick up the element from the queue and give it to me. So we'll say int DQ. Int DQ. And again, when will underflow come? When cursa is 0 and you are trying to do a underflow, DQ. So we will say if, we should take care of the special cases before. If cursa is equal 0, then return -1 right away there. Don't proceed with the rest of the code. Okay. Else means there is something in the queue which can be dequeued. Okay. And what should be the operation? You remove from the head, remember? You have to take the head out. That means head is not null. Otherwise cursa will be 0. So what we should do? We should advance the head. Now, if it is a single node, then you have to be careful because head will become null. And in that case, tail also should be made null. Right? Okay, we'll see that. Okay. There is something in the list, so I can get rid of it. So, how do I get rid of it? Now, I want to get temp is equal to heads first. So, I'll say temp is equal to head first. My temp will point to the head. This guy is going to go away. Okay. Temp is equal to head. I am making temp point there. Achha, have we created temp? No, we need to create temp. Just temp as a struct node star. You don't need a malloc. Because we are not allocating it. We are just using it as a pointer. Semicolon. So temp is equal to head. Temp is pointing to head. Now what do we do? What should be our next line? So we have to retrieve the value in temp in some variable like v, because that is what needs to get returned. So we'll say int v value. Okay, yeah, let's go slowly. So temp is equal to head, v is equal to either head's data or temp's data. It's the same. Okay, temp's data. Okay. Yeah. Then head should move ahead. Head is equal to heads first, heads next. Head is equal to heads next. Then what? Free, not temp. You can free head also. No, you can't free head now. We have to say free temp, the old head. Free temp and return v. Wait. Yeah. Before I return, I should reduce the cur size. Cur size equal to cur size minus 1. Now, those of you are a little particular, this will work, but those of you are a little particular, what you can do, if cur size has become 0, you can make tail also as null. It will not do harm, but if you want to be a little more careful, by that, if cur size, it won't matter because we are working on the head, and as long as we are updated head, we are fine. If head becomes null, we know it's the first node, and reassign tail. So return v. Let's go back and see whether our DQ is working. I'll just walk through DQ again. Come down. If cur size equal 0, I am giving back return minus 1. I don't have anything to do with this queue, DQ, because there is nothing in the queue. Then else, I am creating a temporary pointer called temp. I am creating a variable v. Temp is pointing to head. I am taking temp's data, that is the head's data, and putting it in v, because that is what I want to give. Head is advancing to head next. The temp is going. The old head has to be knocked off, because head has to move forward. Then size has to diminish, and v has to be returned. So if the proof of the pudding is true, is there, this should give no test case. I mean, this should pass test case, right? So let's check. We'll run it. Check the first thing, 10, 20, 30, 40, 50, 70 and minus 1, correct. And I should get initially overflow. So let's check, evaluate. Okay. So we got the test case also through. Okay, now I'm going to give you this code. It's 11:20. I'm going to give you this code. With this, we finish our syllabus as such. Stop here. We'll give you this question. Okay, practice lab 52. Those of you who are not able to understand, it has the complete code. It has add node, it has push, pop, delete node. I think it has almost everything. Okay, so please take that code, study it again. It is complete. We have not removed anything, except the main may change depending on what you need. But rest of it is all there. All functions are there. Everything is there, whatever we have developed with you. Okay, so please go through that code. It's called Practice Lab 52. Yeah. So we have opened it, started it. So if you want, you can play with it, but code is there. So please study it carefully.